Okay, so here we are. We got BM and AC are perpendicular. AM is congruent to CM, and we want to find CM. So we got BM is perpendicular to AC, and then it tells us that AM, this distance here, is congruent to CM, this distance here. And the question is find the length of CM. Well, since CM and AM are congruent, the measure of AM is 4, so the measure of CM is going to have to be 4 as well. All right, number 2, BM and AC are perpendicular. AM is congruent to CM. Find the length of BC. So from B to C here. All right, so since we know that BM is perpendicular to AC and that AM and CM are congruent, that means that BM has to be a perpendicular bisector, and any point on the perpendicular bisector is supposed to be equidistant to the points, or the endpoints of the segment it's perpendicular to. And so since B to A is 12, going to that endpoint of AC, then B to C, going to this endpoint of AC, should be the same. So therefore, the length of BC is going to be 12. And 3, BM is the perpendicular bisector of AC, because AD equals CD equals 17. So distance from A to D and C to D is both 17. And what can we conclude about point D? Well, since D happens to be equidistant from A and C, then what we know is that it has to be on the perpendicular bisector. So we're going to say point D is equidistant from both point A and point C. So D is on the perpendicular bisector of AC, which in this case happens to be line BM. I could write there. Line BM, not BB. All right. So then exercises 4 through 6, complete the statement with the word inside, on, or outside for perpendicular bisectors. So we're talking about perpendicular bisectors of triangles. And so number 4, in a right triangle, the point of concurrency is blank the triangle. So easier way to look at this is if we actually have a right triangle here. And if we want to look at the perpendicular bisectors, just roughly sketching those in, looking at what's about the midpoint on each side. We'll go perpendicular, and so on a right triangle, it's actually on the triangle. A little off on my freehand there, but that should be right there on that hypotenuse. So then number 5, in an obtuse triangle, the point of concurrency is blank the triangle. So if I get an obtuse triangle here, and then do the same thing, kind of freehand perpendicular bisectors in there. like that. So in this case, we would see that the point of concurrency is outside the triangle. And in an acute triangle, so let's look at one of those real quick. So an acute triangle, if I freehand perpendicular bisectors in each one of those, there we would see that would be inside the triangle. And so really the trend is that for these perpendicular bisectors, the bigger the angles get, the farther towards the outside the point of concurrency moves. All right, so on a acute triangle where the angles are small, it's right in the center just about. A right triangle, so we're getting to a bigger angle, 90 degrees. They end up right on the triangle. And then we get to an obtuse triangle, then the point of concurrency moves outside the triangle. And that is a rule that works in every case for those certain triangles and the perpendicular bisectors. Moving on to number 7. So in exercises 7 and 8, see the diagram to indicate the measure. And I see that says Sue. Let's say C, the diagram to indicate the measure. So perpendicular bisectors of triangle ABC meet at point D. Find the length of BD. All right, so we're talking about the perpendicular bisectors. These segments here, so ED, FD, and GD are all perpendicular bisectors to the sides of that triangle. And when we have the perpendicular bisectors, the point of concurrency, D, just a little added information, D is the circumcenter. And the circumcenter, once we've got it created based on these perpendicular bisectors coming from the sides, we should know that the circumcenter is equidistant from each of the vertices. So D to B should be the same length as D to A and D to C. So 7 wants us to find the length of BD. Well, BD, since it's the distance from the circumcenter to a vertex, should be the same as D to A. And D to A is 11.5. So the length of BD should be 11.5. And in the same case, DC is just another distance from the circumcenter to another vertex. But once again, it's supposed to be equidistant, so DC should be 11.5 as well. All right, so 9 through 13 here. Complete the statement with the word always, sometimes, or never. So the perpendicular bisectors of a triangle will always, sometimes, or never intersect on the triangle. Well, perpendicular bisectors, we just did those over here, and we saw that we did intersect on the triangle if it was a right triangle, but not if it was an acute triangle or an obtuse triangle. So that would be sometimes. The angle bisectors will always, sometimes, or never intersect outside the triangle. And this is one of those rules we learned when we went over the angle bisectors of a triangle, was that that intersection, that point of concurrency, will always be on the inside of the triangle. So that's a never. It will never intersect outside the triangle. 11, the medians of an acute triangle will always, sometimes, or never intersect inside the triangle. And once again, with an acute triangle, if we look at an acute triangle, one here, and so if I'm looking at an acute triangle, remember the medians go from a vertex to the midpoint of the opposite side, so just freehanding from the vertex to what looks like the midpoint of the other side for each one. And notice that's going to be inside, and that's going to work every time for every acute triangle. So the answer there is going to be always. 12, the medians of an obtuse triangle will sometimes, always, or never intersect on the triangle. So with an obtuse triangle, we do the medians there. Once again, that's from the vertex to the midpoint of the opposite side, like that. Something like that. And notice that this is inside the triangle even with an obtuse triangle. So it's not going to be on the triangle. So that's going to be never. And then 13, perpendicular bisectors of an obtuse triangle will always, sometimes, or never intersect outside the triangle. And with an obtuse triangle and the perpendicular bisectors, remember this rule, the rule for perpendicular bisectors is the bigger the angles get, the farther towards the outside of the triangle the intersections are going to get. So with an obtuse triangle and the perpendicular bisectors, it's always going to be outside the triangle. Right? If it gets down to a right triangle, it's on the triangle, and acute triangle, it's inside for the perpendicular bisectors. All right, so 14 through 17, use the diagram and the given information. V is the centroid of triangle RST. SU and RT are perpendicular. The length of UT is 10. The length of RW is 6.25. The length of SV equals 5. And RS is, the length of RS is equal to the length of TS. So RS and TS are the same. It tells us that V is the centroid, which if V is the centroid, then TW, RX, and SU are all going to be medians, meaning they're going from a vertex to the midpoint of the other side. So everywhere on the outside, we've got a measure on one side of that midpoint, then we know the measure on the other side of that midpoint is going to be the same. So if RW is 6.25, then WS is going to be 6.25, which then we would know that the entire length of RS is 6.25 plus 6.25, or 12.5. And so if RS is 12.5 and tells us that RS is equal to TS, and TS is the same thing as ST, doesn't matter what order they're in, it's still the same segment, whether we look at it as T to S or S to T. So if we're trying to find S to T, it should be the same length as RS. which in this case is going to be 12.5. And so then SU, so from S to U, one thing we know is since this is a centroid at point V, the distance from a vertex to the centroid is 2/3 of the total length of the entire segment. So that 5 should equal 2/3 of the entire segment SU. And so to solve for the length of SU, we would divide by the 2/3, and dividing by 2/3 is the same thing as multiplying by the reciprocal, 3/2. So that's going to be 15/2 equals SU, and 15 divided by 2 is going to be 7.5. So the length of SU is 7.5. Length of ST is 12.5. Now we want to find the length of just U to V, and UV should be 1/3 of the total length since S to V is 2/3. And so UV equals 1/3 of the total of 7.5. So that would be 7.5/3. Divide that out. And we're going to get 2.5 for VU, which I guess we could have also looked at SV being 5 and SU was 7.5. We could have subtracted 5 from 7.5, would still give us 2.5 there. And now lastly, find the perimeter of triangle RST. So we need to add up all three sides. We know this is 12.5, 12.5, and then we got 10 here from U to T, but SU, since it goes to the centroid, has to be a median, meaning that U would be the midpoint of RT. So if UT is 10, then RU is 10, giving us a total length down here of 10 plus 10, or 20. And so the perimeter is going to be simply those three sides added together. So 12.5 plus 12.5 plus 20. So that's 25 plus 20, or 45. All right, so number 18, 19, and 20 wants us to find the value of x. And when we look at these, what we notice is we got a little segment here inside of each one of these triangles, and where those segments go through, the sides of the triangle, or the portions of the sides of the triangle on each side of that segment, are congruent. So that means that where these segments are hitting the sides of the triangle have to be the midpoints of the triangle, or the sides of the triangle. So that means that each one of these is what we call a midsegment. And a midsegment, we should remember, is parallel to the side it's opposite of. So this segment here should be parallel with this side down here. And a midsegment is also half the length of the side it's opposite to. So that's the information I need in order to be able to solve these. Since each one of these is a midsegment, then the length of each midsegment should be half of the length of the side that they're parallel to. So in this case, for number 18, x should be equal to half of 3x minus 10. So this x is half of 3x minus 10. or the length of this segment, is half of the length of this segment. So to get rid of the half, or to move it to the other side, we can divide by 1/2. And dividing by 1/2 is the same thing as multiplying by its reciprocal, which is 2/1 or just 2. So that gives us 2x equals 3x minus 10. And then we can solve for the x, move the 3x over. That gives us negative x equals negative 10. Or lastly, divide by -1 to get that to be a positive. And we end up with x equals 10 there. And we quickly check if that segment's 10 and the x is 10, so that means that 3 times 10 minus 10 is the length of this side right here, or 30 minus 10, which is 20. And so the side of the triangle should be twice the length of the mid-segment, which 20 is twice the length of 10, so that works. 19. Once again, the mid-segment should be equal to half the length of the side. So 2x plus 23 should be equal to half of 8x. Now in this case, since it's just 8x here and we're multiplying it by 1/2 instead of dividing by 1/2 and multiplying everything over here by 2, we could just multiply 8x by 1/2, and that's going to give us 2x plus 23 equals 4x. Move the 2x over. So now we got 23 is equal to 2x. Divide by the 2. And 11.5 is equal to x. All right, then number 20. Again, 5x minus 3 here is on a mid-segment, since we can see that the segments, or the portions of each side, are congruent on each side of that mid-segment. So 5x minus 3 should be equal to half of x plus 12. So move the half over, divide by the half, or on the other side we're multiplying by its reciprocal, 2/1 or just 2. Distribute that through. Get 10x minus 6 equals x plus 12. And then work to solve it. So subtract the x. So 9x minus 6 equals 12. Add the 6 to both sides. 9x equals 18. And lastly, divide by the 9. X equals 2. All right, so exercise 21-22, list the sides in order from the shortest to the longest. All right, so this is going back to the theorem that tells us that the side opposite a shorter side is going to be, or the side opposite a smaller angle is going to be shorter than the side opposite a larger angle. So if we're putting them in order from shortest to longest, we got one angle here which is marked as a right angle, so that's 90 degrees. We got 50 degrees there, and we kind of need to know what the third angle is. So A is going to be 180 minus these other two angles, minus 90 minus 50, or 180 minus 140, which is going to be 40 degrees. So that's 40 degrees there for A. So we got 40, 50, 90. So angle A is the shortest, or the smallest angle. So the side opposite that, BC, should be the shortest side. So BC And the next bigger angle is 50 degrees, so the side opposite of it, CA, will be the next longest. And the 90-degree angle is the largest angle in the triangle, so the side opposite of it should be the longest side. So that would be side BA. So BC, CA, BA, or CB, AC, AB. The order within the segment name doesn't matter. All right, so 22, got 108, 40, and we're missing O, so we're going to have to calculate it. So that's going to be 180 minus 108 minus 40. Well, that's 180 minus 148, which will be 32. So O is 32, N's 40, M is 108. So O is the smallest angle. So the side opposite that angle is going to be the shortest side. So that is NM, being the shortest side. Then the next one's going to be opposite the 40-degree angle. So that would be MO. And then the longest side is going to be opposite the biggest angle, which is 108 degrees. So that is NO. All right, so exercises 23 and 24 list the angles in order from smallest to largest. So now we're looking at the sides and trying to make a decision about the angles. So same idea. In this case, we're just in reverse. The longer the side, the bigger the angle is across from that side. So you got 3, 4, 5. So 3 is the smallest side, or the shortest side. So the smallest angle is going to be angle T. So the measure of angle T is going to be the smallest angle. And then 4 is the next bigger number. So the angle opposite of 4 right there is S. The measure of angle S. And then lastly, ST is 5, which is the longest side of this triangle. So the angle opposite it is going to be the largest angle. So measure of angle R is going to be our largest. All right, 24, same idea. 18, 19, 26. So 18 is the smallest angle. So measure of angle I is going to be the smallest measure. 19 is the next bigger. So across from it is angle G. So measure angle G is going to be the next biggest. And 26 is the longest side. So opposite 26 is going to be angle H. All right, so then last little section here, in exercises 25 and 26, determine whether it is possible to draw a triangle with the sides of the given lengths. Write yes or no. So we've got 2, 4, and 6, or 9, 12, and 18. And so in this case, the rule is that any two sides added together have to be bigger than the third side. So I can generally want to check the two smaller angles and see if I add the two small angles together if they are bigger than the largest angle. So in this case, the two smallest angles are 2 and 4. So in order for this to be a triangle, 2 plus 4 has to be greater than the third side, which is 6. And we end up with 2 plus 4 is 6. Trying to say that 6 is greater than 6, which is not true. So since we didn't come up with a number greater than the third side by adding the other two sides together, this one is not a triangle. Those three sides will not be able to make a triangle. All right, so then it asks us to explain. And so basically to explain it, I'm going to say because the sides of measure 2, and 4 do not have a sum greater than the third side, of length 6, these sides will not make a triangle. So then number 26, got 9, 12, and 18. So check and make sure any two sides added together are greater than the third side. So 9 plus 12 should be greater than the third side, 18. So 9 plus 12 is 21, which is greater than 18, so that works. And theoretically, you needed to know it for all of them. Of course, once you know it for the two smallest ones, it should work for all of them, but we can go ahead and check. So 9 plus 18 is greater than 12. That's 27 is greater than 12, which that definitely works. And then you can do 12 plus 18 is greater than the third side, 9. And 12 plus 18 is 30, which is definitely greater than 9. So that checks out. So that concludes the review. Hopefully I've answered any questions that you have. If not, make sure you bring those ready to ask on Monday when we take the test. Ask before I hand it out, please. And we will see you then. You should be able to find this video on YouTube under Brian Howell, my geometry YouTube page. So have a good weekend. We'll see you Monday, ready for the test.